So the next thing is just is the calculate the open swell drainage connected to the city. So if there's more, if there's runoff generated, we want to make sure, okay, what is, how to, drain them away. What kind of pipe, if we don't need pipes, how we design open swell to drain them um, to other places, like the river or something. Um, so the major formula we're gonna use is Q equals AV. Q is basically the rainfall intensity, and A is the area, cross section area of our open swell, and the V is the velocity. Um, and the chart we're gonna looking at is this one, extreme event. So you want to pick this one. So you want to know, okay, how large is this? What's the number of here? So in this case, is kind of 0.4 inches per hour is in the 10-year extreme event. Okay, if we change to second, then that's, this is a unit. Okay, um, and you use if we use Q, um, but what we need is quantity. Okay, that's the first step. We want to know the quantity. So the quantity is, you want to use the area of your site multiplied by this inch per hour, which inch per second here. Um, so the area of our site, we know our area is 6 acres, so that's why it's here. And this is basically the intensity, and then we do some unit calculations, and in the end we get feet per second. The reason we need feet per second is we want to consistent with the velocity here, because you see here the velocity is from, we pick velocity using this chart. This chart is feet per second. Okay, so then we'll know the quantity. So the quantity, we know our site will generate 2.42 cubic feet per second of runoff, okay, during this extreme event. And this velocity, and we can select from chart below based on the material of the open swell. If we use Kentucky grass, we know to pick a slope of the grass, what kind of soil it is. So in this case, we pick this 7 feet second. It's like this one in the middle. Um, so we know the V. So once we know the Q, we know the V, we can calculate A. Okay, so A is here, so we can calculate A equals 0.34 square feet. So basically that is the, so we, after this we will know, okay, if we draw open swell, so we know this area how large they are. Okay, that's what this number means. Okay, so after this done, we know the A, we is this much, and then we know the V. The V, you know we know it from this chart, right? And we need to calculate this Manning's R, um, which we need to find out Manning's Raffles coefficient from this table. Well, our open swell usually is vegetation, so we pick 0.03 in here, but we want to use this formula, and S is channel slope, the slope. This is basically what we defined. In this case, we use 3%, so it's here too. Um, so that's pretty much what we're looking for. Sorry, the Mannings we pick 0.03 here, which is this n. Okay, so then you just calculate it, and then you get R. So this R is the Manning's R. Okay, um, but here's the point. The reason we calculate Manning's is we want to get a sense, of if we design pipe, what it gonna looks like. That's basically what it is. Most of the time, you don't have to do that. Okay, that's my point. Um, but things we're trying to be more rigid, so we need to do it in this class. Okay, so once we know the Mannings, we can use we can calculate depths, and what we're gonna use in here is we want to use the width using this kind of manganese, like 1.5% of manganese. So as width, we just use that as a convention, I guess. So then sin is 2.4, so it's width. So once we know the width and we know the A, and we can calculate D in this using this formula. Okay, so we have A here and we have D here. So once we have A, we have D, we're able to get, so this is basically W and this is D. So basically, we know how to design an open swale at this point. Okay, so all these are required for this class. Okay, and then in the textbook, you have to calculate another thing. It's called this kind of thing called hydraulic radius. So basically, you want to use this. Basically, you use a W here, you use a D here, and calculate another R, which is here. Okay, as long as this R is smaller than manganese, which means our open swale it will really make sense. Okay, so that's basically the goal. Okay, so the general process is you have to find a Q, and you have to find a V, and you get an A. Once you get an A, you are able to you are able to go to next step, and then you use manganese by once because you know the V and you know the slope, you basically define that. So this here is the slope, and then you go to here, find the manganese, and then you calculate an R, and then you use 1.5 times of R as W, which is the width, and then you know the A from here, then you get the D. That's basically what we're doing here. Okay, that's pretty much it. And there's things in here too. You want a hydraulic radius, you can check. You calculate this R and you can check whether or not it makes sense. That's pretty much it. Thanks.